How does gravity really work? Welcome to our channel. Today, we're going to explore the fascinating concept of gravity and how it really works. Gravity is a force that affects everything in the universe, from the smallest objects to the largest celestial bodies. But what exactly is gravity, and how does it function? At its core, gravity is a force of attraction between two objects with mass. This means that everything with mass, including you, me, and even the Earth itself, exerts a gravitational pull on other objects. The strength of this gravitational force depends on two main factors: the mass of the objects and the distance between them. According to Sir Isaac Newton's law of universal gravitation, the more massive an object, the stronger its gravitational pull. For example, the Earth is much more massive than a basketball, which is why the Earth pulls the basketball toward it when dropped. Now let's talk about distance. The gravitational force decreases as the distance between two objects increases. This means that if you were to move further away from the Earth, the gravitational pull you feel would become weaker. This is why astronauts in space experience a sensation of weightlessness. They are far enough from the Earth's surface that the gravitational pull is significantly reduced, even though gravity is still acting on them. In the early 20th century, Albert Einstein introduced a groundbreaking perspective on gravity with his theory of general relativity. Einstein proposed that gravity is not just a force, but a curvature of space-time caused by mass. To visualize this, imagine placing a heavy ball on a stretched rubber sheet. The ball creates a dip in the sheet, and if you roll a smaller ball nearby, it will spiral toward the heavier ball due to the curvature. This analogy helps us understand how massive objects like planets and stars warp the fabric of space-time, causing other objects to follow curved paths around them. This concept of gravity explains why planets orbit stars and why galaxies are structured the way they are. It also accounts for phenomena like gravitational lensing, where light from distant stars bends around massive objects, allowing us to observe celestial bodies that would otherwise be hidden from view. Gravity is also essential for the formation of the universe. After the Big Bang, gravity played a crucial role in pulling matter together, forming stars, galaxies, and eventually planets. Without gravity, the universe would be a very different place, lacking the structure and order we see today. So, the next time you drop something or gaze up at the night sky, remember that gravity is at work, shaping our reality in ways we are still discovering. If you found this exploration of gravity intriguing, click our logo on the right side below. Don't forget to like, comment, and subscribe to our channel. Click the notification bell to stay updated on our latest videos. Thank you for watching, and we'll see you in the next video.